slash kind of the warm-up-in class. First thing we're going to look at is the idea of angular speed versus linear velocity, and how does switching your tire size affect your speedometer if you don't actually get it adjusted. And so we're going to take a look at the idea of Lee putting 36-inch tires on his truck to help him get better off-road abilities, and then he's going to be driving down 405 to Bellevue and gets pulled over for speeding. He swears that he's only doing 60 miles an hour, which is what his speedometer says, but the state trooper insists that he's doing at least 67. Let's prove how they could both be right. Then the next piece we'll look at, if most cops won't write you a ticket until you're doing more than 5 over, will he get stopped on a 35 mile an hour road if his speedometer says he's doing 35? So the big thing we're going to take a look at is we know that our velocity, linear velocity, is going to equal whatever the radius of our object is that's spinning times our omega, which the omega is that theta over time idea. The actual units for that would be important if we're trying to find RPMs, which we can definitely do with some unit conversion stuff, but for the most part, we know that the tire is spinning the same speed both according to our speedometer and in actual real life, so we don't really care what unit it's in. We can just say that if I know I'm doing 60 miles per hour with a 32-inch tire, so 16-inch radius, that my omega can be written as 60 divided by 16, or 3.75. I know also that what my actual speed is with a bigger tire, so now my unknown velocity with our bigger tires, 36-inch, so 18 radius, with the same rotations, so now this wheel is spinning the same speed, which again is 3.75, or that's 60 over 16. How fast am I actually traveling now with a bigger tire? Well, same number of revolutions, bigger tire means that I'm actually doing about 67.5 miles per hour as our velocity. So yes, I am speeding, and that state trooper is going to pull you over. So let's take a quick look then. What if I'm driving on a 35 mile an hour road? Same idea. My speedometer thinks I'm doing 35 based on my 32-inch stock tire. So there's my new omega with weird units. Again, if we want to find the RPMs, we can do some unit conversions and find that. That's how your RPM gauge works. But since we know these W's are going to be the same, we don't need to go too much more in depth. We know there's a linear relationship. So my true velocity with an 18-inch radius on a wheel doing 35 over 16 is going to end up being 39.375. So I will be just underneath that 40 mile an hour mark where I'd probably get ticketed. But life lesson of the day, if you get bigger tires on your car, make sure you get your speedometer checked so that you're not speeding. Same idea if you get smaller tires on your car, you should probably also get your speedometer checked so you're not driving super slow when you think you're doing the speed limit. So anyways, adjusting the wheel will adjust your linear velocity. Next thing we're going to take a look at is today's stuff, which is the idea of our trig identities. So we're going to look at a toolbox that's got a whole bunch of the things for us, which I believe is on page 654. So 654 has your toolbox for you. The most important pieces, I think, is to recognize that sine goes together with cosecant. So it's 1 over cosecant. I also think it's important for us to know cosine goes together with secant. And tangent goes together with cotangent. So these are what they call the reciprocal identities. And so these will kind of help us when we start playing some of these games. The other thing that's important is to identify that tangent, in terms of sine and cosine, is sine over cosine. which the way I try to remember that is if we think about how our coordinate points on our unit circle are x comma y's, we know that this is cosine comma sine. And so I try to remember that tangent is the same as rise over run. So it's our y over our x. So that's the way I try to remember it. Now the other one that I want us to make sure we have is the Pythagorean identity. So we're going to look at the idea that if I build any right triangle on our unit circle, we can build that triangle off of it where our base or our x value again is cosine, and then our height is sine, and our radius on a unit circle is 1. So if we go back and recall that Pythagorean theorem states a squared plus b squared equals c squared, then we can come up with the conclusion that cosine squared plus sine squared must equal 1 squared. So that's where we get that Pythagorean identity. So there's a handful of other ones inside your toolbox which are good to know, but these I think are the most important if you're going to try to memorize stuff, because then based off of this, you're able to actually derive all of these other things. So let's look at a couple examples. If I was doing something like number 15, I want to show that sine theta times cotangent is going to be equal to cosine. Biggest thing of what we're going to do the next week is you're going to take one side and change it. Try not to move things left and right across the equal sign. Only deal with one side or the other. Don't let things cross because we're trying to prove these identities. So one way is to try to get everything into terms of sine and cosine. In this particular case, I can say this is sine times cosine over sine, which is our definition of cotangent, which could be derived from tangent being sine over cosine and then 1 over. So it flips it. Then we notice that our sines will cancel top and bottom, so we end up with cosine theta. And then once both sides look the same, we've proven our identity. So that's what we're looking for. Something a little bit more complicated. Let's take a look at number 20. Number 20, we want to take a look at tangent times the quantity of cotangent plus tangent will equal secant squared. Okay. So again, I like to start with the things that are the uglier side to make them simple. So I'm going to try to focus on this side over here. And so if I distribute that tangent through, we'll end up with a cotangent times tangent and plus a tangent times tangent, which gives us a tangent squared. And then tan times cotan actually is 1, since those are the reciprocals of each other. So we end up with 1 plus tan squared theta. If you wanted to, you could break that down a little bit more and look at how that is sine over cosine times cosine over sine. And again, that shows you how those actually will turn into this 1. And then if you look at your toolbox, we actually see that 1 plus tangent squared is defined as secant squared. And so at that point, we are able to create our true identity. If you were to take it a little bit further out, we could get common denominators and work through it that way, where we'd end up with 1 over cosine squared, which is secant squared, but we'll take a look at that a little bit later on as we continue through these. So for the most part, use your toolbox in some of those key concepts, and then you should be able to derive everything else. Good luck tonight.